videos have come really convenient because my afternoon class has used them a couple times. So I do really like getting that recording in. So in your plan book is chapter 5 PDM. You might put like a star there and say this is quarter 3. So it should be a high priority. I'd say I'm sorry, Meredith. I'd say I'm sorry, but I'm not really because we haven't had very much mastery work this quarter. So like we need to at least fit in another mastery just because of pacing and how much stuff is going to land in quarter 4. But this needs done. So really, if you can do it tonight, it's your homework. But don't freak out because we're going to work on it together in class. We're going to pick some of the hardest ones or problems that, maybe we haven't done before because I forgot to teach us. I think we did a little bit with compound probability, but not a ton. So the biggest, most important thing here, well, not biggest, most important, but all of your answers will go on graph paper. So right now, if you don't have graph paper, get graph paper. If you don't have a ruler, you're probably going to want a ruler. If you don't have a highlighter, you probably want a highlighter. Get everything that you need to have an effective work session for the next 6 minutes.
If I haven't finished my other homework this week tomorrow?
So guys, chapter 6 work will be quarter 4. You should prioritize this assignment higher than your chapter 6 practice.
Okay.
This should be the number 1 math thing you're doing, unless you still have old revisions, which why do you have old revisions?
Which then why are you? Why do you exist?
Exactly.
All right, we're going to do a few of these, and a couple of them should be quick as we get going. And then a couple of the later ones will probably need more time, but I need you with me, right? So today, it's vital. And like nobody should be sketching during this class period because there are 15 questions on the sheet. Guaranteed we can't get them all done during class because that'd be 2 minutes per question at this point. We start the class kind of late.
Man, who would have thought that you were good at that?
Why does this say spiny torture?
Man, not me. Because that's Spiny Torture Middle School. Yeah.
Oh my gosh!
So at Spiny Torture Middle School, 35% of the classrooms are for 6th graders. So you might, with your handy-dandy highlighter, highlight 35 are for 6th graders. If there are 49 6th grade classes, how many classrooms are there in total? So we can easily set this up with our percent diagram. 100% of spiny torture. And then 35%, right? Put that somewhere that feels like 35%, which means that this region, how much percent would be left over if this was already 35%? 65, right? So we could go ahead and label this missing portion. You should be doing this on graph paper. Just a reminder, Nick, you should be doing this on graph paper. Unless you, you can highlight on the paper, but your answers, what you draw. Guys, I did not leave you enough space on this handout because I only wanted it to be 1 sheet of paper. Think about it. That is a difference of 50 pages of paper. 1 page versus 2 pages of a handout to you. It makes a huge difference. Graph paper is a lesser stock. It uses less tree. No joke. That's why I would rather you use graph paper. It uses less resources. So, they then tell us that 49 is the amount of the 6th grade classrooms. Now, we're doing 1 because number 2 is easier. Number 2 is a multiple of 10, so you could jump your attention over to number 2 really quick and highlight the important stuff in number 2. But here, if we think about our 10% rule, we have 35% is equal to 49. if we just, and guys, I genuinely am doing this with you. I haven't made my key yet. I chose what problems I wanted us to do. But if we wanted to try to get to 10%, you know, that little chunk to break things up, because then we could get to total pretty easy, right? What would I divide by to get down to 10%? 3.5, right? Because to go from 35 to 10, because make it easier for a second, what would we do if it was 30 to 10? We would divide by 3. That would be easy. But 35 makes it slightly harder. So if we divide by 3.5, I don't know if this is going to work out nice, but if it does, we should use it. What's 49 divided by 3.5?
Some number.
14. It works nice. Is it 14? Like just straight up 14? So guys, then how do we go to 100%? 14 times 10. So how many total classrooms? 140. Guys, that is the same thing you're going to do for number 2 on your own. But, give me your eyes up here. In number 2, they give you the discount that he paid. You don't know the total price of the jacket or whatever it is, but they tell you the percent he paid and the dollars he paid. You need to figure out what the price of the jacket was. Again, go down to 10% and work it from there. Yes?
What's like before the discount?
Yeah, what the normal price of the jacket was, what 100% would have been. Because he pays, what, 80%?
Yeah.
Yeah, because if it's 20% off, he paid 80%. But we're skipping that one and we're moving on to number 3. So please move on to number 3 with me. Skip number 2. I'm not going to come back 5 minutes later when you say, oh, wait, I was doing number 2. Can you go back to number 3? I'm not going to. Lily.
Should we leave a space so that we can do number
If you want, sure, that'd be good. I mean, and number 2 should take about the same space as number 1 did. Okay, just leave yourself that same amount of space. Vic has 3 pairs of pants. He's a simple man. By the way, don't judge Vic. Vic's got his own style. Okay. Blue, brown, and black. He's got 2 dress shirts, white and striped. He can also wear a yellow or green tie. Again, Lydia's like, come on, Vic.
Yellow
Get it
tie.
together.
Yellow tie.
Hey, I have a yellow tie. If you're wearing like a green shirt or a black shirt, like sometimes a yellow tie looks
Why would you
nice.
wear
Well, but
This
you have
was in
you
a
have
black
a tie that has with the Santa hats on it.
Probably not. I'm not really a holiday tie
It's
guy.
like
Yeah,
you know,
it
for the last
works if
time.
you have like a black top.
So guys, we all kept messing this up. Almost all of us, I agree. Almost all of us, okay, most of us, almost all might be a lot, kept putting the like, you were writing like pants, shirt. Like, that's not what we write at the end of the, like, branch, right? This is literally what we call, if you're like me, you're probably putting on your pants first. So he's choosing his pants, but how many pants does he have? 3. So this should have 3 branches, and I could off to the side or somewhere like label pants if I want, but I don't have to. What do I put at the ends of the branches? You can also go left to right. I mean, you can, but then you're not going to put shirts. It's not really good to put pants at the top because it feels like that's the only thing happening. So at the ends of our branches, we're writing the results, right? Not pants, shirt, tie. We're writing blue, black,
Can we just do? Oh no, we can't.
brown.
Oh, we can't.
Now you could have done EKN if you wanted, like use the last letters or any coding that you choose. You could. So then, I should really random card this. Let's start random carding for today.
Okay.
Morgan, what do I do now? Sure, but how do I do tie or shirt? I branch out from each of these, so I'm just going to change colors just because. So these, my pants, I did blue branch. My shirts, I guess we'll put our shirt on before we put our tie on. That would probably make sense. We have white or striped. Okay, so that we can abbreviate white or striped. White or striped. Again, we're putting the results, not shirts. We're putting the results. Eric, what do I do next?
Then you scream off for the ties for yellow or green. But can I just say something? If you've suggested this, then you're crazy. Who puts on a tie before they put on a shirt?
We didn't suggest that. We put on our shirt before we put on the tie.
I'm just saying.
Yeah, how the heck would that
No one
work?
does that.
Why do you buy? Why do none of these work? I don't like these outfit choices. If you're gonna wear something formal, you're gonna wear
Don't
How
judge
can you
me.
just cause a
You wore lobster swim trunks in February as your shorts. Not like to a pool party, but like as what you wore. So, hey, hold up. I'm trying to help you on the other problem, like number 6.
You wear these dress shirts and like all this every day.
So this, if I circle this, what is that, Meredith? What is this? Because actually, this is an outfit I would wear. If we go up, we have to follow the tree up.
So it's brown pants,
White shirt.
and then a green tie.
Yeah, I would have worn that in college, like khaki, like brown pants, a white shirt, and a green tie. It depends on shading. Oh, you judgmental.
And if you're wearing a belt.
So look at B. If he chooses an outfit randomly, what is the probability he will get black pants and striped shirt? We're not looking at the tie. We're looking at black pants. Okay, black pants. So black pants, that doesn't really write. We'll go silver. Black pants and striped shirt. But both of these are black pants, striped shirt. So if I go all the way down here, I have to circle both of these or ignore everything red and just look up here. 1, 2, 3, 4, 5, 6. At this point, he has 6 options. That's 1. So for B, this should be 1 out of 6 because if we just look at this level before he picks a tie, or maybe he chooses not to put on a tie, what is the chance he gets black pants, striped shirt? That's right there. If we go down to here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 twelfths is 1/6.
Why don't you use the top one?
We can use either. It's the same. Whether I use these two.
Like the blue, black, and brown.
What do you mean? Why don't I use the top one?
Like, why don't you count those?
Because those are. We have to count where we end. So thank you for that question. Excuse me. Jumped up. These are part of the final result. So what you're talking about is the final result. Hey Molly, you with me?
Yeah.
The final result is black pants and a striped shirt. That outfit is this. This is not an outfit. This is part of it. Now, this is a final outfit, and this is a final outfit if we put on the tie. But if we don't, if we just stop right here, there's 6 outfits. One of them is black pants, striped shirt. So guys, that's a great question. Why do you keep messing up? We don't count up here because those are just parts of the outfit. In 6, look at 6 for a moment, it asks you to make a table similar to this, except notice he only is dealing with pants and shirts. So because there are 3 options here, we said tables don't work. 3 options is too many options for a table. But 2 options works for a table. So in 6, you could tree diagram. There are a lot of people that I hope are listening, but they're not looking. You could tree diagram. but it asks you to create a probability table. Okay, so you could do both. But I want to see a table to represent it like we did yesterday. We made those tables together. Yeah. So if he chooses his outfit randomly, what is his probability? He'll get blue pants, white shirt, green tie. Is that going to be different than the first weird outfit I brought up?
Yeah.
Blue pants, white shirt, green tie. It's different. So what I circled in black up there, what was that probability? We said 112.
And then the next one was 1. So it's the same.
Blue pants, white shirt, green tie. Blue pants, white shirt, green tie. At the end, it's just one of the outfits out of 12. So this is 112. Just like my initial, like brown, white, green, that was 112. Each of these outfits at the bottom is 112. Any questions on that one? I want to look at 4 because it's going to guide us, and actually you can write on this paper. It's going to guide us through a couple of the future problems. Just give me just a second to go ahead and look at 4, like read it real fast. I give you the table, right? I decided to be nice because I knew I was giving you a lot of work. We're at the end of the quarter. So it's a little small, but I give you the table of when I roll the die, the outcomes are 1, 2, 3, 4, 5, 6. When I flip the coin, the outcomes are heads, tails. So in the table is what came up on the coin and what happened on the die. Kind of makes sense. I hope it makes sense. That's why I put it on here. Now, I want to talk about how we calculate these without a table. If you think about getting, hey, bring your attention back to me because I'm about to show you math I don't think I taught you well enough. I think I'm serious. So the probability of getting a heads when we flip a coin is what? A half, right? Like I think everyone could say when you flip a coin, your chance is a half if you want one of the results. When I roll a die, what's my chance of getting a 6? A 6, a d6. We're rolling a d6. What's my chance of getting a 6? 1/6, right? When I look at this table, here are the outcomes. How many outcomes are there? 12. And heads and a 6 is how many of them? To do compound probability, all you need to do is, yes, all you need to do is multiply the fractions. So if you are not given a table, hint, hint, nudge, nudge, later on this paper, you're not given a table, and you're asked a probability question about this thing happening and then this other thing happening, we just multiply the probabilities. So if we look at heads, what was our chance of heads? A half. And an odd number. What's the chance of getting an odd number on a d6? A half. What's that chance come out to be? A fourth. Or I could come up here and say, okay, heads and an odd, heads and an odd, heads and an odd, and that's 3 out of 12, which reduces to 1/4, or I could have just done the math and multiply them together. Tails and a number less than 6. Well, what's my probability of tails? Half. What's my probability of less than 6? 5, right? 5 out of 6. So this gets 5/12. That's how we do compound probability.
What's that red writing that you cut off?
That was if I circle
Oh, that's
and I just look for how many heads and odd there are, it comes out the same as if I calculate.
yeah.
So if you look at 5, that's how you're gonna do number 5, right? All of those probabilities on that spinner are equally split. But be careful, and I would highlight this if I was you. What's the trapdoor of 5?
There's 2 sedans in one spinner.
There's 2 sedans in one spinner. So sedan is not a 1/3 chance. You should mark this on your paper right now. Sedan is actually a 2/3 chance. Be careful. It's not 1/2, even though it's one of two results. It's 2 out of 3.
Because if it was a half, it'd have to be 1 and half of.
It'd have to be a third,
Half of a third.
half of a 1/3 and a half of a third.
Yeah. If you were splitting it.
1/3 and
Hey, keep going to the back. Sorry about how this looks. This is what happens with Word. And I was going to change it to like Mr. Estes, but now he's sick, so I felt bad. But these spinners go with this problem, and they go with these questions. Like, obviously they're all related. But again, I know you could fit your answers over here. Please do it on your graph paper. So 7, same skill set as number 6. Or, sorry, number 5. With the spinners and multiplying the fractions. Same stuff. We're doing the same stuff in 7 as we do there. Go on to 8, since it's kind of more difficult. Yeah, Toby.
For when we're solving the problems with the graph and the wheels, not the spinner, but the circle of pies. There we go. You want us to draw the pies on in the table?
What do you mean? Like, what problem are you talking about?
Like number 5, we have the pie that has like the chance of sedan, truck, and sedan.
Yeah. You don't need to draw these on your graph paper. No. That's why I put them on this paper for you. The other reason I wanted you working on graph paper so you could look at this right on the other thing. You know what I mean? What's up? Yeah. Do you want a water bottle? I mean, if you want to take a walk, that's fine. But I have water bottles. Not 5. I was looking for this. Go to 8. We're not going to solve the whole thing, but we're going to solve a tiny bit of it. So I know I have 9 copied in here too. We're going to talk about 9 here in a second. But in 8, all right. These spinners are broken up kind of even. I mean, the left one's 8ths, right? The right one's 4ths. Really, if you want to like talk common denominators. I just wanted to like stop and make a note about this. You win if the spinners match. So we're going to talk about one of these. If I want to calculate the probability of winning, I need to calculate all 3 matching situations. So when we talk about winning with red, I'm just choosing red because it's the first color I'm thinking of. When we talk about winning with red, sorry, that's a very odd R. I've never made an R that looks like that before. We need, what is the chance of getting red on both? So, Rhea, how do I do that?
Oh, you have to calculate. You have to add them. Well, first you need to make a common denominator.
Don't. Yeah, this is why we're pausing to talk about this. To get the probability of red, I need red on spinner 1 and red on spinner 2. What's the probability of getting red on spinner 1? Half. What's the probability of getting red on spinner 2? But to make both of those things happen, we have to multiply these. So the probability of getting matching red spins is 1/8. You're going to do the same for blue and get an answer. And you're going to do the same for green and get an answer. And then, because we want any of those results, I don't have to multiply these because I don't want and, I want or, right? Matching red or matching blue or matching green. We will add these 3 probabilities. So that is when common denominators are going to come into play. But until then, we don't actually have to worry about common denominators because remember, multiplying fractions is actually easier. Oh, friends. My copy cut off a triangle. We all need to draw a triangle for 15 real fast. Yeah, thank you for people that said okay. To my Weiner powders, get over it. The triangle that we should have had. I want to make sure that I do the right thing. Yeah, this is where I make my tests. So this is the newest test I made. Actually, if I show it to you right now, it'll show you the answer. Alright, here we go. So here's your triangle for 15. I need you to draw this on your paper. It doesn't have to look like this, but on the one side, we have x plus 2. On the other side, we have 2x plus 3. And on the other side, we have 3x minus 2. I try. Look, I was not deceptive at all. You guys assumed.
Sooner or later, you'll end up in court for scamming little kids.
I highly doubt that. But if I do, you'll be the first person I call, Rico. I'll get your phone number from Infinite Campus. I'll be like, you know what? You were right, man. Here I am in court for scamming little children.
I'm not even sure that's a crime.
Molly, I just drew this on your paper because it's the only thing you really missed while you were out. My copy cut this off. It probably just didn't fit, and when I ran front back, it just didn't go. But that's the triangle for 15. Somebody give me a request. Do you want 11, 12, 13, 14, 12?
It says 5D process. I'm not scared.
Well, you don't have. Well, okay. So remember, I told you, even if I forget to delete where it says the 5D process, you don't have to do it. Right? So actually, I'm going to undo and go to a new page. I kind of like orange. It's like a nice, subtle, kind of chill. If I change it, I'd probably try to make it look more like a chalkboard. You know what I mean? Because I'd rather it be like even less bright.
What about blue?
I like writing in blue. And if I make the background too dark, I can't write in all the colors I like. But that's so boring. I need like 8 different colors at a minimum.
What?
You should get like light green.
Like a chalkboard.
A rope is 84 meters long, cut into 2 pieces.
You should use like a neon green or a neon pink. You make the screen black, see look for all the colors.
Besides black.
But he never uses black. That's not true. Blue is boring. Whoa! What is this?
He's entering the Matrix.
We're doing yes,
Forget what you're all bugging me about is that.
That looks so cool. Whoa! You have a gradient? That's awesome. Make it black. I like the green one. You should get like a light green. Yeah, do that one. Yeah, gray. Yeah, do that one. Oh yeah, that's hot. That's
Perfect.
Really?
That means you still use all your colors in it more.
You should get like one side green and then one side orange.
No.
Then you can still have like one color.
Never lived
Solid
with
color.
Nick.
I'm
In
just
third grade, my teacher used that background. She wasn't very nice. I'm having flashbacks. Oh.
Toby, what you're having is a moment of immaturity. Come back to us in 7th grade. Get over the things that have happened in the past. You know that.
You can't push back.
Not even going to talk about other teachers. You're here with me now. Are you safe? Yes.
No.
Are you happy?
No.
Yeah, it's whatever. I gave you homework.
Toby.
Long is 18 meters longer. So long, how do I express what long is?
Write it.
Oh!
Greater than?
That's longer, like, that's more than or greater than. When we say longer than, we're talking about, like, adding more. So, now it's because you're thinking chapter 6. You're thinking what we're doing now, and we're now in the past. We're thinking back a week or two ago. We jumped with Doc in the DeLorean, and, you know, we're back in So it's the short side, plus 18. Please be careful you aren't like me and then go back and look at your S and think it's a 5 and, like, you know, things go bad. So S is S. Oh, this is easy. Guys, I want you to get in the habit of trying to do the algebra. Don't do the 5D process because it's a longer, kind of time-wasting process. What we know is S plus L equals 84. What we can replace, see the left side is just a little bit dark, is we can replace L with S plus 18. That's essentially what I just had going on. It was an orange gradient. What do you mean right in orange? I can combine the S's.
It's beautiful. You like that? That's so cool. It's a blessing.
You know what I don't like?
I don't know.
Judgment.
I don't know how to feel about
Morgan?
it. He didn't go to teacher screen in the first place, so why did you? He was peer pressure.
Yeah, he was
peer pressure.
Hey, Morgan's trying to talk. Yeah, get rid of the extra, right? So 18 is extra here. We're trying to solve for S. So we have 2 S's and an extra 18. Get rid of it. So now 2S equals, is it 66? And then if we divide by 2,
Look at that. 33. Like a bomb. So then the one side, 33 plus 18. There's the one row.
so then yeah, we still have to solve for long.
Whoa, that's a really big L.
Is there like a drum concert going on back there that I missed the invite to?
Yes. Oh, they're filming their skit thing.
51?
Yes.
I want you to try 13 right now for a minute.
If you make another page, will it keep the gradient?
No, unless I reset the document to reset to that gradient. Or I could clone and then clear.
Yes. Beautiful.
Try 13. We just literally did this skill, talking about what we have and what's extra. Set up an equation. Try this without talking to your neighbors. Set up an equation that shows the charge of every mile times the amount of miles, right? That's how much they're going to charge you for that. So if I highlight that, it's $4 every mile. And my bet is we're going more than 1 mile.
I would hope. I mean,
But, and guys, this is true. I don't know if you've ever taken an Uber or anything else, but there is a flat fee to get in the car. And I am not making this up. My buddy Seth took an Uber from my house to his house, which was about 5 blocks away. Because it was torrentially downpouring. He had board games with him, and he had walked over. It wasn't raining when he walked over, but as soon as he got in that car, they didn't have to go anywhere. He was charged. Like, there's money you got to pay just to get in the car. Then they drive, and like there's like a meter essentially, not realistically anymore, but there used to actually, in a taxi, you could watch the meter click up the amount of money you were going to owe them until you stopped, and the mileage thing would stop. They'd hit a button, it'd reset back to the initial fee of $6, and then the next person would hop in and start all over again. If Lynn's total cost was $66, try to figure out how many miles she went.
why didn't you just drive them home?
I was asleep. He stayed up later playing. I have a roommate, a friend that lives with me, and they were still playing a game, and I went to bed.
You're boring.
Because we both said you should just leave your games and walk home, and he was like, I don't want to walk home. He makes plenty of money, like too much money.
You should
What
sue
did
him.
they do?
insurance. He's like works for an insurance company.
Is he an actor in the State Farm commercials?
No. Although he'd be a good actor. Let's set this up a piece at a time. Lydia, what did you write down first? Did you write down 4 or 6 or 66 or like 66? There's no wrong answer with how we set this up, guys. You can build it in any way you want as long as you use the pieces appropriately. So 66 is the total fee. So if I wrote this out, 66 is the flat fee and the mileage fee. Like miles, like the dollars for the miles, right? I have some people not doing this with me, and I really fear that you're going to get a progression on this thing and then end up stuck here at Discovery Day. I really don't want that to happen. So, Callie's not here. Oh, yeah, you are. You're hiding back there. What is the flat fee? Luz, what's the mileage fee? So do I just put 4? Yeah, I need to put something here, X or M or whatever, because that's going to happen $4 every mile. 1 mile, $4. 2 miles, $8. 3 miles, $12. 4 miles. Keeps going. Nikki?
What I did is I just took 66 and subtracted the flat fee.
Why?
Because to find the mileage, you don't need.
Yeah. This includes the flat fee. To find the mileage, we don't want to include the flat fee. So the math is kind of easy here. Take 6 away, that makes our number better. Oh, but you keep using cards. I even called on you when it wasn't your card. So Molly, if I'm trying to find just M, what do I need to get rid of now? The 4, how's the 4 attached? Yeah, how's it attached though? What's the operation? What's this? Yeah, times. So what's the opposite of times? Yeah, so we can just divide by the 4, and M is 15 miles.
Is that a good price for 15 miles? 66?
It depends. So Uber has all kinds of different fee structures. Depending on what's going on in Columbus, like literally they set their pricing based off what's happening. So for those of you who are curious,
Are you getting an Uber right now?
Yep. If I were to call for an Uber,
You should call them right now just to talk.
it's gonna ask me where I'm going. It pulls up where are there Ubers around us. So if I was going to like Newport, let's say I'm going to go see a concert at Newport Music Hall. So let's say we want to take the whole class. It's an Uber. It just tells me the whole rate. So you don't even like know what is flat, what is mileage. They just literally tell you what you got to pay. Now, in reality, what has happened is Uber's done the calculation of how much do we charge them just to pick them up, and then how much do we charge them to get them there. Now, the other thing happening in this is Uber taking some of that money, the person driving you gets some of that money, and then probably some third-party company for credit card charges or whatever gets a little bit of that money also. So, yeah, and you can get like an Uber Black is like super fancy and all, like, yeah. So then there's Lime scooters somewhere close. So, and that's probably about 15 miles. Right, what if we're going to the airport? There you go. Not here.
Is this something a helicopter?
Alright, here's what's up. We did like at least 5 of those problems. The rest of that is your homework. You should be able to at least start those problems, if you hit a snag, come see me. When you turn this in, guys, this is what you're going to do wrong. When you turn this in, you are going to do me a personal favor and make my life easier. You're going to put this new graph paper on the tippy top. The sheet that you just got today will go below that. And then in whatever order, your other Chapter 5 Mastery and Revisions pages goes below that. So the new work you're doing is on top. I didn't tell you to, so come get it back. The thing we worked on yesterday, the Chapter 5, you should not have, so like Morgan, you should take this back, Savannah, you should take this back. I don't want these yet. Morgan's really mad, apparently. I just want you to take your paper back, Morgan. You don't have to throw a stool at Toby.
Who's the murderer now?
Still you, Toby. Still
I don't think I have yours.
Wow.
Alright, get out of here, go to Goldring.
What does that paper look like?
I don't know what it would cost to get to Kashak.
Mr. Clinton, use a paper clip. Is it this paper? Yeah. Do you
I
have
do.
one of those pinchy clips?
Holy cannoli! It would cost me $100 to get to my hometown.
Do you have
and
one of
everything.
these I could use?
What? Unless are you going to bring it back to me?